I'd just like to introduce Dr. Anna Lehman from BC Children's Hospital. She's one of the mitochondrial doctors that works at BC Children's, and she has a lot to tell you.
Thank you very much for inviting me. I'm a local clinician. My experience with Leber, I've had the privilege to work with about 10 families who've been affected, so definitely a very different experience from our experts here. I'm a clinical geneticist. I'm not a neuro-ophthalmologist. I have a special interest in inborn errors in metabolism, including mitochondrial diseases, and Leber's is a mitochondrial disorder. I work both at Children's in Vancouver General with adults, and we work as part of a multidisciplinary team. So I'm a physician, but we also have a genetic counselor. I was hoping she was going to be able to give the talk today, which is focused on genetic counseling issues, but she wasn't able. But I think I can do an okay job here. So we can have the slides.
Sorry, I'm not sure which one you were.
Lehman is my last name.
Okay, hang on 2 seconds. Sorry.
So I should be able to go through some of the slides more quickly because a lot of the material was already covered by the previous talks. Might be able to get us back.
This one. Sorry.
Should I go get?
Nope, it's okay.
Stick?
Okay, it's.
Yeah.
Yep. Okay, 2 seconds. There we go. Sorry.
All right, great. Roll them. Yeah, I have no financial disclosures to make. Only disclaimer, some of the things that I will say are representing my own opinion. Please see your doctor for personalized advice. Brief history of the genetics. It was first described as a condition in 1858 by von Graff, but it's not von Graff's disease, it's Leber's disease, because he was the one who recognized that it tended to be transmitted through moms, and there was the gender bias for who would be affected more. It was noted in 1936, just when we were really starting to get a handle on genes being the little transmitters of heredity, that there was inheritance not through the nucleus and all the normal genes, the 22,000 usual genes, but through something in the cytoplasm of the cell, something not in the nucleus. And then Erickson in 1972 proposed that in fact it was a mutation in the mitochondrial DNA. You all know the story, I'm sure, about how mitochondria eons ago were likely their own form of bacteria that merged with a more complex bacteria. Great symbiotic, mutually beneficial relationship ensued, and the rest is history. Wallace, in 1988, found the 11778 variant, and I put his picture up, and he is still incredibly active researcher in the field of mitochondrial disease. So we heard already about the 3 main variants. There's 11 variants that have strong evidence, and then 20 plus variants that the jury is still out for, would need some more evidence for certainty about whether or not they're causing the condition. Concept of heteroplasmy is really important to understand for my talk especially. Heteroplasmy, which is where not all of the mitochondria have the variant, it can be found in up to 15% of carriers. And it's thought that once you get up to a heteroplasmic load or a mutation load of about 70%, that's enough to be affected or at risk of being affected. How is the genetic testing done? People always ask this question right away. Sounds very involved, but it's just a blood test. So fortunately, unlike some other mitochondrial disorders, we don't need to get a muscle biopsy or anything. We can just look at the mitochondrial DNA in the blood. Thanks to technology, genetic testing has gotten quite inexpensive. And in fact, it's pretty easy to test all of the mitochondrial DNA in one go for only a little bit more money than just testing the 3 main mutations. So currently in our clinic, we just do the whole mitochondrial DNA in one go. We do the test for someone who's presenting with their visual loss. I need to go back and see more. Once a family's variant has been identified, if we want to do testing of just that variant, then it should be less than $300 Canadian to just do that one test. Just caveats, I wasn't sure exactly moving out, but my practice, I also consider when I'm having a patient who's had this subacute onset of visual loss, I do think about some other genes too. It's not all just Leber, and if there was young age onset or positive family history, for virtually the same price, we check a box, and we check for a couple of other genes too. And then if there's additional neurologic problems, then we consider doing much broader testing, because optic atrophy can be one feature of many, many, many different genetic disorders. So I loved the previous talk so much, because I'm so flummoxed by this paper from 2008, where it was found that 1 in 333 individuals are born with one of those 3 main LHON variants. And they found that a third of those, because they were able to check the moms. So basically, 3,000 babies were born and had a set of mitochondrial DNA mutations sequenced. So just random population, babies getting born, check, check, check. So what does de novo mean? It means they couldn't find it in the blood of the mother. So new. So we hear about these families that go on for hundreds of years. Once it is there and homoplasmic, it's there. But it has to start new in someone at some time, because we don't all have it. So when you're looking just in a general random population, you find it more frequently that it could be new for the time. And not all of those people, though, was it at a high level. So that's what the little graph with the dots is showing. Basically, we've got the red dots are is the 1444, blue is the 11778, and then green is the 3460. And so you can see the Leber mutations. There's a lot of people out there with a high level of percentage of the heteroplasm getting over that 70% mark. So about 1 in 1,000, we'd estimate from this small data set would be homoplasmic for a LHON variant. I'm very excited as a geneticist about a large data set called NOMAD that is showing us what the genomes of hundreds of thousands of people look like, so that we can understand what the real variation is. They haven't yet released the mitochondrial DNA, but they have it. They've analyzed it. They haven't published it or posted it yet, but that's going to happen very soon, and that will be very helpful. Next. So the penetrance issue. The reason why I'm making a big deal about this is 2 of the 10 families that I've been involved in the care of, no one in their family has had optic atrophy. And they were identified because of that new technological advance I mentioned, with how great and easy and cheap it is to just check all the genes at once. Someone in their family was getting this broad testing of all the genes for other reasons. And there was an incidental finding that they carried one of the LHON variants. And now they're in my clinic. They're big families. What do I do with them? No one has had optic atrophy. So we heard about some reasons for why it's so high in the general population, but it's still a rare disease with the prevalence of, we say, 1 in 30,000 in the northeast of England, 1 in 50,000 in the Finnish population. Gene reviews. Do I tell the families 50% chance for your males to have do I say that to them? I didn't. I mean, I said this is what's in the literature, but no one in your family's had it. And 10% for the females, which we changed here. So the numbers just don't quite add up. Is it just that we've ascertained all of our information from the families that have been affected, and it's that J haplotype and other factors that's playing the role? Do we need to add that into our clinical genetic testing? I hope we can soon. Currently, you can't check a box. Check for the J haplotype, but not possible yet clinically. So next slide, please. So those all of our data came from families like this, the families we've been seeing. So it's what we call an ascertainment bias, if that's where we're getting our information from families that have had people affected. Okay, should relatives be offered carrier testing? So, Dr. Crowley is here. This is where my opinion comes into play. I'm not sure I should ask him, how to interpret this, because the consensus guideline says strong consensus that it's not necessary to perform genetic screening for the LHON mutation in all maternally related family members. Okay, I offered. I don't know if it's a bad thing.
I'm like you, actually.
Oh, good.
but the majority didn't know.
Okay, so in Canada, well, in BC, we have provincial healthcare systems, and I've convinced our public insurer that this should be paid for. It's not that expensive. And you know, in my mind, well, I'll get to the reasons later, but what we offer, genetic counseling, we offer a family information letter to help facilitate discussions with family members. We offer appointments to those family members, education, testing for anyone who wants it, referral to ophthalmologists. We have great neuro-ophthalmologists that we can refer them to for their screening proactively. So why might someone want the care? We've already heard great reasons, ready to act early. It is not good right now in our healthcare system for how quickly someone would get diagnosed with this disorder. It's not acceptable. I'm right now my genetic counselor and I are trying to put together some information on how, because accessing the testing is a bit bureaucratic and complicated. We're trying to streamline it, working with the labs, working with our insurer, and then we're going to try to work with the ophthalmologist and Claire Sheldon and to get the word out and try to make it as quick and easy as possible. So we have work to do. We're working on it. The lifestyle, and then for some, would it inform their family planning? Next. Why someone might not want carrier testing. Well, people generally, the biggest concern that anyone has when they're deciding not to do any kind of genetic test in general is just worries about insurance discrimination. So, you know, we're good for healthcare in Canada that wise, but there's, you know, issues around disability insurance, life insurance, and so forth. And we do have this Genetic Non-Discrimination Act, which means no employer, no insurance is allowed to ask for the result of a genetic test. But it hasn't really been thoroughly tested in the court system to see how much protection it practically offers. Insurance companies can still ask about family history all they want. So we'll see. I don't, when I talk to families about that, I don't make any promises. Like, oh, don't worry about it. It'll never be an issue for your insurance. You know, so the other reasons, and also the Genetic Non-Discrimination Act, if I understand, is being contested in the Quebec courts, I think, right now, on the premise that province is supposed to regulate the insurance company, not the federal government, so a little bit of a technicality there, so we'll see what happens with that. Just people don't want to, you know, maybe an older male who's outlived his high-risk period, he doesn't really just want to bother to, like, make the trip down to Vancouver or even do a phone appointment or so forth. Or they're just, you know, we've explained the empiric odds based on how closely they are related to the person, where they are in the pedigree, you know, with, well, okay, look, you are a carrier, do you want to have this appointment or not? Maybe they're like, no, okay, I believe your math, and so forth. Next. So if my matrilinear relative has it, should I just assume, well, maybe that's reasonable depending where you are in the pedigree. But being a geneticist who just, I only see rare things, and so you always see the exceptions to the rules. And considering the potential for de novo events and heteroplasmy, I still offer the test. And another reason I do that is the last point is the privacy concerns. I like the idea of everyone's medical record being as separate as it can be from their families, and they've got their own report with their name on it in their record, you know, that they carry the variant, rather than photocopying the relative's report and putting it in the other person's chart. It's only a couple of $100. I think it's worth it. And a third of families in the small series have at least one relative with heteroplasmy. So, you know, if I don't know for sure who it started with and who's got it, then I'm going to offer the testing. In our clinic, I was just curious, like, how were we doing with our genetic counseling and our education, and how much were families feeling comfortable talking to their relatives about this? And so we did a survey of our patients, and we didn't have the highest survey uptake. I think we about a third of people we invited completed the survey, and some variety of different mitochondrial disorders. And we asked, you know, were they talking to their families? Were they informing their families about this? It turned out that everyone was. So I felt good about that they were comfortable to bring it up, so it was not an interesting study result just to find out everybody does pretty much. We also wanted to know how well we were doing with our education piece about the genetics, and so we included in the survey a 6-question knowledge quiz, and people did really well. So everyone got either 5 or 6 out of 6 correct. And so one of the questions was being shown a pedigree and having to pick out, who would be likely to have the variant in their family. Like, who should they really be talking to about it? So that was really reassuring too. And next slide. Reasons, we asked them, why they were wanting to talk to their family members, and either they were worried someone was going to be affected, or that just the family member would want to know, that the family member would want to be tested, or they wanted their family to just understand more about what they were personally going through, what their diagnosis was, and or they thought they were less likely to say that there would be a direct benefit for the family members to be tested, but they did highly value just having their family members be informed, which is great. Next slide. So I thought we should just briefly talk about it here at the end of my talk. It came up already. I thought it was really well covered. The whole idea of donor mitochondria. I mean, I find that a bit of a 3 parents thing, but I think that it's such a tiny amount of DNA, right? We're talking about 37 genes versus the 22,000 that are in the nucleus. It's not really going to change biologically the person very much relative to their parents. What about the question of having the change in those 37 genes? I don't know. There's so that was, if I understand correctly, in the late 90s. There was a different technique used for couples who were having infertility with the embryos not being very healthy, and so they did a cytoplasmic transfer, which included a lot of the mitochondria. And so there are 20-year-olds who have lived, at least so far, seemingly healthy from a survey that was done follow-up for them in 2016, who have the 3rd parent DNA. But there's still a lot of unknowns about it. But it's certainly exciting to follow how this goes down the road. So the Newcastle NHS is just offering it only domestically right now. It is an expensive and involved process. There are some other clinics that I googled and you can find online. I'd stick with Newcastle myself. Being the ones who are really tracking, so that's what the UK has tasked them with, to really make sure that this is a safe thing to do. Here in Canada, they do a lot of techniques. So in terms of the technicalities, if it does seem to be safe, I think it would just be a matter of time that it would come into Canada, because they're doing cytoplasmic transfer for other reasons, but they're just transferring from other cells from the same person to themselves. But it could come. Concern, well, there still be some mitochondria with the LHON variant present. Could there be a reversion in a few generations down the line? Other concerns. Show the next slide, which just shows a picture of how that works. You take your donor egg, take your own egg, you fertilize, and basically you take out the donor's nucleus, and then you put in yours, so that all the mitochondria in the egg are from the rest of the eggs from the donor. So. Alyssa spoke to me a few months ago about what do I talk about, and she mentioned to me these great little videos on the website. So I watched them, I endorse them. they're great. I will definitely recommend them to my patients going forward in the future. And so that's what I came here to tell you today.
Good.